number 1 is the actual real number system. So recall that it begins with natural numbers that are inside of whole numbers, that are inside of integers, rational numbers, and then real numbers. And of course, remember that we had our triangle here of our imaginary numbers. So keeping that in mind, we would say that whole numbers are inside of rational numbers, inside of real numbers. That one sounds like a winner. Whole numbers are not irrational numbers. They're not inside of the triangle. Natural numbers are also not irrational. And this one kind of goes backwards. It's saying real is inside of the whole numbers. Moving on to number 2. Number 2, most of us did in class, and we made a number line, starting with 0. And you guys were very quick to put on 2. Right there. And of course, negative 26 over here. And then the rest kind of confused us. Well, somebody said that negative 1.2 over negative 1.2 is reduces to 1, so 1 would go right here. So I'm going to put 1.2 over 1.2. And then, of course, the square root of 9 is, well, the same as 3. So square root of 9 goes over here. And lastly, some of you guys changed this to negative 0.75. So if I had a negative 1 here, it would go right over here. Oops, negative 3/4. Now, descending order means from greatest to least. So that means I would start with negative square root of 9, 2, 1.2 over 1.2, negative 3/4, and negative 26. Beautiful. Next one, classify. Square root of 25 over 3 into proper number systems. So I'm asking, where does the square root of 25 over 3 belong? In here. Of course, you would want to take the square root of 25 over 3. The square root of 25 is, of course, 5. 5/3 cannot be reduced down to a whole number, so that would be a rational number that goes inside of the cube. Now, rational is inside of the real number system, D. Number 4, I'm asking you to simplify this expression. There is not an equal sign. I'm not going to solve it. All right, so first step here would be to distribute. And I'll keep it in the same color scheme that we had before. So distribute. That would give me 21 minus 3x plus 6x minus 18. Next, of course, I would combine like terms. I would, of course, take my variables first. When you combine like terms, you are adding, so that would be 3x. And I would take my constants at the end, 18, 19, 20, 21. So when I combine those, that gives me plus 3. So I'll rewrite over here a little bit neater. 3x plus 3. Number 5, a lot of us had asked for that one during class. What I had recommended is that you refer back to page 3. And on page 3, we had discussed that this says 1/4, parentheses mean groups, 1/4 groups of 20. Yes, that is a division sign, but we use the word over. So I went ahead and rewrote it so that it looked the way it sounds. 1/4 groups of 20 over 5 plus 3. Now, recollect PEMDAS. At this point, I just want you to get it done. PEMDAS, that is parentheses, exponent, multiplication, division, addition, subtraction. So I'm going to do what's in the parentheses first. 24 over 5, that's 24, or sorry, that's 20 divided by 5. And of course, that would give us 4. So I'm going to bring everything down. 1/4 of 4. Some of you guys kind of struggled with that, so what I had suggested is put it over 1. Now the beauty of that is that whenever you are multiplying fractions, you simply multiply across. So that would give us 4 over 4, which we all know 4 over 4 reduces to 1, leaving me with 1 plus 3 is, 4. And that's our first page.